Learning Outcome 4.5. Calculate frequency response and impulse response given linear, constant coefficient differential equations. When we have an LTI system, we have our input x on the left, our output y on the right, and if our input is an impulse, then our output will be the impulse response. If it is an LTI system, we also know that the output will be x of t convolved with that h of t. So if we have y of t is x of t convolved with h of t, taking the Fourier transform and using the property of convolution, y of j omega, which comes from the Fourier transform of y of t, will be x of j omega, Fourier transform of x of t, times h of j omega, which is the Fourier transform of h of t. It is times because from the system properties, learning outcome 4.3, convolution in time is multiplication in frequency. So what do we do with differential equations? Remember, we're talking about linear, constant coefficient ones, so all of these are going to be constants, no t's out here, no squareds. We want to take the Fourier transform of this differential equation. We can do this by applying the system property of differentiation in time, which, if you recall, says that if our signal is x of t has a Fourier transform of x of j omega, therefore the derivative of x of t will have a Fourier transform of j omega times x of j omega. Look at table 4.1. Therefore, our y of t will be y of j omega. The 2 carries down from linearity, plus because of linearity. Y prime becomes j omega y of j omega from the differentiation property. 3 from linearity property, plus from linearity property. Okay, 2 derivatives here. It's a little bit different, but we're going to do it twice, which means we're going to have this j omega squared, that differentiation twice. That squared becomes because we have a second derivative. On the right-hand side, x prime of t becomes j omega x of j omega, and minus 2x of t becomes minus 2x of j omega. We have the minus 2 because of linearity. A lot of this you're going to do automatically, but make sure you know which properties you're actually applying. Now we can notice that we have 3 y of j omegas on the left and 2 x of j omegas on the right. So we can factor our y of j omega out. We can factor our x of j omega out. Remember, we said on the previous slide that because y of t is x of t convolve h of t, y of j omega is x of j omega times h of j omega. Therefore, if we solve for y of j omega, this quantity here has to be our h of j omega. Now, what was that h of j omega? That's called the frequency response. It is the same thing you saw in Chapter 3 that you found using eigenfunction methods. This does not supersede that. You now have 2 tools, and which one to use depends on how the problem is phrased. Okay, so where do we go now? We've got our differential equation. We have our frequency response. How do we get our impulse response? The other topic in this learning outcome. Well, h of j omega is just the Fourier transform of h of t, which means that h of t is just the inverse Fourier transform of our h of j omega. How do we find that inverse Fourier transform? Well, if we have our h of j omega and its polynomials in j omega, we're going to factor the denominator and then use partial fractions. Okay, let's use a residual method. For this first term, what value of j omega makes this term go to 0? Negative 2. Plug a negative 2 in here, plug a negative 2 in here. What value of j omega makes this term go to 0? J omega equals negative 1. Plug a negative 1 in here, plug a negative 1 in here. And there we go. We've succeeded in doing h of j omega and it is probably faster than you can type this into your calculator. Now we're ready to invert. Look in your table 4.2, which has a whole bunch of common Fourier transform pairs, and you will find we have through linearity, the 4 comes down. Through linearity, the plus comes down. Through linearity, the negative 3 comes down. And 1 over j omega plus a is e to the minus a t u of t. Here a is 2, here a is 1. These u of t's are very, very important. Your answer is wrong if you do not include them. So now we've taken a differential equation, we've found a frequency response, and then by inverting that frequency response, we have found our impulse response. Those are the goals of this learning outcome.